Now, having plotted the raw data and having established that the relationship between our dependent variable here and our independent variable here is a square root relationship, what we next need to do is transform our independent variable, which in this case is mass, so that we can linearize the data and therefore obtain an equation and an approximation of the uncertainty. So we'll do that now, and to do that we're going to have to go back to the table in which we charted all our data. So if we go back to here, so we know that we have to take the square root of the independent variable. So our new column is going to be SQRT, and that was the mass, and that's measured in square root kgs. Whatever we do to the unit, whatever we do to the variable, we also have to do to the unit. And we push equal SQRT, open bracket, and the one we want to square root is the mass. And then we want to just complete that column, so it square roots every value of the mass. You can check one or two values just to make sure that it does look like it's square rooted it correctly, which it does. And we're going to need an uncertainty in that value. So and that's going to be measured in also in square root kg. Oops. Okay, and to work out the uncertainty in the square root of the mass, what we have to do is take the relative or percentage uncertainty in the mass, and because we've square rooted it, we've raised it to the power of a half, so we have to multiply the relative uncertainty by a half and then turn it back into an absolute uncertainty. And to do that as an equation, we push equals, and the relative uncertainty in the mass is this divided by this. That'll give us the uncertainty as a fraction of 1. And then we're going to have to multiply that by a half, because we've raised the mass to the power of a half when we square rooted it. And then to turn it back into an absolute uncertainty in the square root of the mass, we take that new relative uncertainty and we multiply it by the value of the square root of mass. Okay, and then we'll complete that column. You might find that you end up with lots of decimal places. I think I've already adjusted this column to have the correct number of decimal places. And we want it to the same number of decimal places. Basically, we want only one significant figure. So you might have to adjust the rows individually depending on the values that you get. And we want all of these to have the correct number of, the same number of decimal places as our uncertainty, which they do at the moment. Okay, you might need to adjust those by using these extra decimal places or fewer, which causes the program to round that a little bit more. Okay, so now we have the square root of the mass. Now we need to go back to our graph, and we'll do that here. And we need to add a couple of columns here. So we go to Data, New Manual Column. This one will be the square root of mass. And that's square root m, and that's square root kilograms. Done. And then data, we want a column for the uncertainties. Uncertainty in square root m. And the units for that are also square root kilograms. And we also, now that we're plotting our transformed variable, which is the good one, the one that we have to read the equation of, we also need an uncertainty in the time period. So I'll add a column for that as well. And that'll be in seconds. Done. Okay, and then we'll take all that data here from our table. So we want the square root of mass. That goes in here. We want the uncertainty in the square root of mass. And we want the uncertainty in the period. That goes here. Okay. So now we have all of the data in this table. So I have this raw data graph. I think I want to keep that as a graph. I could just change this and adjust it. But I think I want to keep the raw data graph and just create a new graph. So I'll go to Insert, Graph. There we go. And we'll create a new one. It's plotted something weird here, but we'll fix that. Okay. The other thing is I need to just tell this which columns are uncertainties. So if I double-click on the time period here, I either get this column definition where I've already written everything in, or I get options. And I want error bar calculations, and I'm going to use the column uncertainty in time period. Done. And then the square root of mass also needs an uncertainty. Use column, and I'm going to use the column uncertainty in square root of mass. Done. Okay, and then I'm going to plot period against square root of mass, and then I'm going to auto scale so that I get all the data, and there it is. And then I'm going to analyze and add a linear fit to this. So now I have something that looks a lot like the graph that I want. So I'll double click here and add a title. So this is the period versus square root of mass. Done. And now the only thing that remains really is adding the error lines. So I'll do that in a separate video because that's a fairly time-consuming and fiddly process. So you should be able to get up to this point, and we'll have a look at the last bit, and then we'll end up by checking how we can format the whole report.